So next up, we're going to go into a different component of the overall system, which is the vault. The vault is, Jose is actually the engineer on the vault, so he's probably best qualified to even introduce its capabilities. This is one of those situations where I've introduced it a lot, but when the person who wrote it's next to you, it's always a little bit harder. So I'll pass it to Jose.
Okay, good afternoon, everybody. So the title of this talk was actually engineered by this man in front of me. I have to actually add a disclaimer here and say that in this session, you will not actually learn to break into a physical vault, although I can recommend some good movies that make it look very, very easy. So what am I going to talk about? So a bit of background on terminology in terms of what a vault is in the physical sense, the electronic sense. And then I'm going to talk through different aspects of the vault, its purpose, its functionality, where it fits architecturally within a Corda node. And I'm going to talk about the Vault APIs. So this session is going to be a little bit more technical. I'm going to actually show some code samples. I'm going to tell you how you interact with the vault from a persistence perspective and how you query the vault. Finally, I'll just touch a little bit on security, not too much, because there's a session later on by my colleagues that will talk a lot more about privacy and some of the aspects that are very relevant to the vault. Finally, I'll talk a little bit about items that are coming along which aren't currently in Corda, but they are going to be engineered in future features. So what is the purpose of the vault? Sorry, I forgot the... So the background. So what is a vault? So in the English sense of the word, it's a roof, basically, in the form of an arch or a series of arches, typical in churches and other large formal buildings. If we take that definition into a bank vault, well, a bank vault also is a similar architectural, physical building, but in this sense, it's a place, it's a secure space where money, valuables, records, and documents are stored. And the Corda vault is very much the same thing, but it's an electronic vault. And if you're familiar with the concept of a wallet, so a cryptocurrency wallet, which typically stores private keys, it stores your physical coins, or I should say electronic coins, the Corda vault is kind of the same thing, but at a grander level. So it's the electronic storage of the key assets of an organization. And remember, an organization is a physical node on the Corda network. And it maintains all the privacy, keys, certificates, etc. So the purpose. So within Corda, we talk about contracts, and every contract in Corda has states. Those states are the actual the artifacts that are spent. They're the inputs and outputs to commands, and they are the artifacts that are stored in the vault. So you can consider a state as a valuable asset. It could be a fungible state, so it could be something that's spendable, like coins, equities, could be commodities, could be anything that can be gathered together and spent, or it could be something that's a linear state. So a linear state is something that evolves over time. So if you think of a trade in a trade life cycle, that evolves over time, has different states, pre-settlement, post-settlement, etc., etc. So there are two physical types of state. Now, the Corda vault stores these states in the node. So each node has its own vault, and states are stored in that vault if they are relevant. That means if the transaction that's dealing with those states has a key which is relevant to that node, either it's the owner or it's a participant in the transaction. And finally, these states are actually stored in a way that's easy to query and manipulate. And for that reason, we've actually chosen a simple relational model, SQL-based, JDBC-based. So there are two types of data stored in the vault. We've got authoritative data, which is actual transactional data that's been shared between participants. So this is actual ledger data, immutable data that's been agreed, it's been signed, it's been sent between participants. And then we've got what's called off-ledger data, which is data that's relevant to a node and an organization. And many times that data is actually reference historical. It's data that needs to be combined to produce some valuable reporting or some valuable kind of decision making. A third item is that the vault facilitates interoperability and compatibility through a common contract types. So what we envisage happening is that DLT will not just happen all at once. There'll be some step change to get data into a DLT, and we see the vault as a mechanism for getting that data into our Corda network. and that will be through interoperability protocols such as interledger, etc., or it may be just through adapters that converts other contract types from other DLTs into our common contract type. And finally, obviously, the vault holds the really important private key information, which is necessary to be able to sign transactions and to provide proof of who you are. So core functionality, I've already mentioned state. So state in the vault can be in two states. It can be consumed or unconsumed. Consumed state obviously is no longer usable. It's been used. It's either been spent or it's end of life. And then unconsumed state, which is what we call current state, is the state that's used to evolve contracts, and it's used in spending operations. Soft locking. So soft locking is a mechanism that allows, it basically prevents multiple transactions from trying to spend the same states in the vaults. And by doing that, it prevents double spending, which would ultimately be rejected by a notary. But if you imagine there could be many, many flows in a Corda node, they're trying to spend the same states at the same time, we need a mechanism that prevents that happening before notarization rejects that. So in a way, it's a performance optimization. So facilitates fungible asset spending. Fungible assets, as I mentioned, is something that you can aggregate. It's something that you group together. So we have, the vault actually provides a mechanism to say, I want these types of states, I want these lots up until this amount of some issued asset. So in Corda, we have the concept of issuance and assets. And everything that is spent has to be referenced back to the issuer and its reference. So query capability, as I mentioned, the vault is extremely queryable. We've put in place a vault query API that's quite simple to use, but it's very sophisticated in its actual capability. Relevancy checking, as I mentioned, any state that gets into the vault has to pass certain relevancy checks, which include ownership, participant in the transaction, and there are other kind of relevancy checks according to the type of node that's running, whether you're a standard node or whether you're a supervisory observer node. Transaction notes are just descriptive information that you may attach to your transactions. It's something that's in the vault, but it's specific to a particular identity participant on the network. And then we've got some more sophisticated operations. So state reissuance, where you have long transaction chains, state reissuance is the ability for the vault to actually send a transaction back to its original issuer. That issuer will cut the transaction and reissue it so that the long chain that's been produced over time is reissued such that you maintain privacy. So you end up back with a single state and you actually evolve the state from a reissued state. But that reissued state is validated all the way back to the original issuer. State splitting and merging. This is the ability where if you have state splitting and merging actually improves parallelism in spending. So if you have one big state and you've got many flows, transactions trying to spend it, then what we actually want the vault to do is to break that big state up into smaller chunks so you can spend those states in a parallel fashion. And likewise, if states get too small, and this is particularly around fungible states, if they get too small, we want to sort of group them together so we get largeable states, and that can be done automatically based on the kind of characteristics, the runtime spending patterns of the ledger in question. I mentioned security key management, integration, interoperability, and obviously we've got a set of non-functional aspects that we must ensure are covered by the vault. We also ensure that the vault is cross-relational database compliant. So the Corda by default ships with H2, which is a very simple in-memory database. It's part of our open source version, but we actually are validating Corda against other commercial enterprise databases now. And the vault, being a relational database, is being tested in that way. So it's just a diagram that kind of illustrates where this component fits within the node architecture. So Corda itself is composed of a series of services internally. Those services, some of those services are exposed to the public through what we call the Service Hub API. That Service Hub API itself is broken down into two kind of wrappers. One is an RPC wrapper, so you can have Corda applications outside of a node, but the general kind of operational mode is you build plugins. Those plugins use flows. Those flows interact through the Service Hub API. And effectively, all of our services from key management down to the Vault are exposed through these common interfaces. So Vault access. So now I'm going to talk a little bit about the APIs. So what does it mean to access the Vault? So the key point here is that to update the vaults in terms of insert operations and update operations, most of the work is actually done by internal pre-built flows. There are a couple of methods that are exposed to the internal service hub. So in the previous picture, there is a layer that's called the Service Hub Internal API, which is not accessible to Corda applications, but internally, we have two methods on the Vault that allow you to update, to produce inserts, persistent inserts into the Vault. And these internal APIs are called by flows. And there's a single method on the Service Hub API called record transactions, which typically is called by one of the flows that your application will use. So you don't really directly interact with APIs on the Vault, but you do for other things. So we have the public Vault API allows you to do explicit soft lock-in of states. So you can reserve and release states based on some query you may have done for some particular purpose. There's a mechanism to do fungible state spending. I think I mentioned that. And transaction note recording. The other interesting part of the Vault API is that all updates to the Vault are exposed as observables. So we have the concept of reactive RX observables, which mean that data is if you subscribe to Vault updates, you will get Vault update events, and those events provide a list of consumed and unconsumed states, produced states. Right, the query API, as I mentioned, the Vault query API has come along in the last few months. It's a very simple API. It's got two methods. One of them provides a snapshot of data in the Vault as it is today. Another one provides you a track by method, which actually provides a snapshot and a series of streamable updates over time. So you get to see what's in the Vault right now based on your query criteria, plus streaming updates of changes as the Vault's updated. And finally, for those Corda applications that really want to write custom SQL, the Vault API may not be able to accommodate complex joins across tables. So we have actually exposed the ability to just obtain a JDBC session from the Service Hub API. So any of your flows or Corda services can actually just write their own custom queries using standard JDBC. So you can do native queries, native SQL, you can call store procedures, you can call prepared statements, etc. So as I mentioned, transaction recording. All Vault updates are typically, when I say Vault updates here, I mean inserts into the Vault itself, physical inserts into database. They're all performed by flows, and those flows may be pre-built by Corda developers, or they may be pre-built, or they may be flows that are calling other flows. So in Corda, typically you build Corda applications using flows, and it's a hierarchical mechanism. Flows call other subflows, and then at the end of the day, there will be some sort of flow that will actually do the actual persistence. The two most important flows we have are the finality flow. So the finality flow will actually take a transaction, it will send it to a notary, the notary will either approve it or not. The notary will send back its signatures if it's approved, and once that happens, the finality flow will call the record transactions method, and the actual contract states will be persisted into the Vault. The other one is resolve transactions flow, which is used when the notary is doing resolution of a long chain of custody. So basically, resolve transactions flow will actually ask a neighboring node to give all the transactions related to the one it's been given, and it will store them also in the Vault based on the relevancy check. So as I mentioned, if you're writing a custom flow and you don't find a flow within the library you can still record transactions using the Service Hub transactions, record transactions API method. And again, every call to the Vault will trigger an update. And just finally, we have got quite a few test utilities. So in Corda, there's a lot of test utilities in terms of we have a mock network, which allows you to simulate a Corda network within memory. We have mock nodes, we have mock services, and we've got a series of helper methods that allow you to fill a kind of test vault, let's say. So you can fill it with cache, with linear states. You can pretend to consume cache. You can consume and produce. You can evolve linear states. These are just helper methods. And basically, they help you get the vault in a state you want to actually perform some real flow testing. So this is just a little snippet of code. So one of our sample applications that's available is the Yo application, which basically sends a message from one node to another node. So in this example, what you can see is this is part of a flow. And what this is doing, it's basically saying, building up a signed transaction. It's saying it's building a Yo command. That Yo command has got some states. That state is basically me and the person I'm sending to, and it passes in its own key. And then if we just go down to the bottom, the key part is the finality flow. So after signing the transaction, verifying the transaction, we finalize the transaction. That finality flow is the one that ultimately does the notarization and persists the actual states into the vault itself. And likewise, this snippet of code, so this is within that finality flow itself. So the finality flow has a step that does the notarization and recording. And this is where you can see the service hub call that's actually calling record transactions. And that's recording the notarized signed transaction. That will trigger inserts into the vault. So persistence. So as I mentioned, everything in Corda, all contracts in Corda have states. That state is always persisted to an immutable data store in a serialized form. It's also persisted into the vault in a serialized form with attached metadata. So the table at the top is effectively our vault states table. It contains the contract state in a serialized form, and it contains a series of metadata attributes about the state of the contract. Then below that, we've got a separation of types of states. So fungible state has a series of attributes which are very useful for querying. And likewise, linear state also has a series of attributes equally useful for querying. So what we actually do is we actually persist those common attributes as part of a contract that extends either of those interfaces. And then if you build your own Corda application, so cache is a prime example. We have a Corda cache application, which previously was integrated into the vault. Now it's a standalone application. So cache has its own custom schema, and that schema, the only item attribute that's missing is the currency code. Everything else is part of the fungible state definition. So basically the quantity, the owner, the participants, the issuer reference, all of those items are always attached to a fungible state. And just to talk a bit about persistence, so as I mentioned, we use standard relational databases, JPA annotations, which have been standardized for a very long time now. We use Hibernate as the object relational mapper to get from the object state to the relational model. And by using Hibernate, we also leverage the pluggable database provider assistance. And just one other thing, identity queries. Because we store a lot of opaque types, such as identities, we always query on the identity key, which not the opaque key, but we actually identify on a key, which is the hash of the identity for performance. So custom contract schemas. So this just talks you through what you need to do in terms of how do you create your own custom contract schema. So first of all, you have to define a schema object. And that just defines three attributes: a family, a version, and a list of types. Those types themselves are JPA entities, and each JPA entity has the option of either extending persistent state, which will always insert the primary key of a state, which is a state reference. A state reference is a transaction ID, hash, and an index. Or you could extend one of the common states, which in the previous diagram, you could see there was a fungible and a linear state. If you extend those, then all attributes from those states are automatically persisted for you. So once you've defined your JPA entities, you've registered them with a schema object, then what you have to do is in your contract state, you have to implement this queryable state interface. That just tells the contract what schemas it needs to work with. And then the most important method is you have to implement the generated map schema. And that method will actually that provides the logic that says these entities, these attributes from my contract state get mapped to these entity attributes in my relational table. Once that's done, you then can use the contract objects as you would. Those custom schemas will be persisted in the database when you use flows to record transactions. And then you can do queries using my contract state and all the derivatives of that. So just to snip it again. So this is going back to the Yo application. So that's the Yo state. So that's the object state, which is just the origin, target, and the message Yo. Then you can see that it implements the queryable states. The queryable state methods supported schemas, Yo schema 1, v1, which is a single schema. Version 1, it only has one entity called Yo entity. And the mapping in this case is as simple as it can get because it's basically mapping an object, which is Yo, to the state attributes, which are the same ones as the state in the object. But in typical use cases, there'll be a mismatch between what's in the state of the object and what's in the database. And this is the mechanism by which you do that mapping. So the Vault query implementation, as I said earlier, we have it's a very simple query API in the sense that there are two methods, query by and track by. Now, those two methods take several parameters. They take query criteria. There are four types of query criteria. There's a common query criteria that will allow you to query on any of the attributes of the Vault states table. There's a fungible query criteria, and there's a linear state query criteria, which allow you to do filtering, etc., on the other tables. You can also specify pagination. So in a query, you can say how many results you want to come back, and then you can paginate through the result set so you don't get everything in one go, so you can produce proper kind of reports and page sort of UIs. We also support sorting, so you can specify a sort criteria. That can be on any of the common attributes in the state tables, or it can be on your custom attributes as well. All the criteria can be composed, so you can compose custom criteria with general criteria. So give me all consumed states where cache amount is greater than a certain number. You can also specify aggregate functions. So a very simple query may be just give me the balance of all currencies in the vault. And that query uses aggregate functions under the covers. Yeah, that's pretty much it. I've got a lot of examples, but I haven't got any right with me here. So finally, the custom query. So as I mentioned earlier, if what you want to do is just not possible with the Vault query criteria and the query API, you basically just use the service hub, as we talked about earlier. You can get a JDBC session off the service hub, create your complex native query or whatever the query may be, execute the query and do whatever you want with that query. So in this example, I've created a Corda service which will run within the node. That Corda service is just doing a query on the database. It's getting a set of currency strings and amounts, and it's returning a list of those items, amounts of currency. This kind of diagram just illustrates, again, I won't go through a lot of detail, but it's just showing the different ways that Corda applications interact with a node, and it's showing the Vault specifically. So the Vault, core Vault component in the middle there, you can see on ledger data, off ledger data. There's the Vault query API, there's the Vault API itself, and then these are the different types of application you can have in Corda. So you've got remote applications that can be standalone RPC-based. They can be web applications that also use RPC. You can write custom services that have full access to the service hub, or you can write you can write Corda applications that use flows. Those flows can be library flows, or they can be custom flows. And again, a very simple API to start a flow, you call the start flow method, and to start a tracked flow, which is a flow that returns progress information as the flow executes, you run the start tracked flow API call. So this is just kind of illustrating all the different types of API calls you can make to the Vault. And again, the big one, if all else fails on the query side, you get a JDBC session, you can query and join tables from different Corda apps, internal Vault state, or customer off ledger state. Now, I won't go into detail on security, but Corda has been built from the ground up with security in mind. So the whole of Corda is based around a PKI certificate management mechanism. Every node on the network has a legal identity, which has its associated certificate. At the database level, we use authentication and role-based access control. Optionally, we can encrypt the payload. From a transport level perspective, all data on the wire is over TLS or SSL. Internal messaging within a node is using AMQP, which again is a wire protocol which is secured. For RPC access to any flow, you have to provide a username, password, and the flows themselves are permissioned. So you have to specify what flows you allow permission to execute on a node. And then there's a whole range of privacy techniques, which my colleague Mike Hearn is going to go through later on in another presentation. But these are some of the aspects of privacy that actually play well into Corda and into how information is stored in the vaults. Finally, in terms of roadmap, what we're doing next, so some very minor improvements on persistence. We need to track a bit more metadata in terms of what Corda apps are generating states, what flows are being used to generate those states. We'd like to provide multiple JDBC session support, so you can actually access different JDBC connections, not just the internal Corda one. And we've got some work to be done around splitting, merging, reissuance, which I mentioned at the beginning. Coin selection itself is something I haven't talked about, but we do have coin selection implementation. We have a cache application within Corda that does coin selection, and there are many ways of implementing coin selection. That's something we're going to focus on as well. Data distribution group support is a feature that's documented in the Corda white paper, which is not yet in Corda, but it's the ability to have groups of nodes that collaboratively are informed of transactions. And the Vault has a role to play in deciding whether states are relevant based on the data distribution group membership. Soft locking performance optimizations. This is around fungible states. At the moment, we soft lock pretty much all states, but there are optimizations we can do where it's not necessary to soft lock individual states depending on the pattern in play. Finally, there's a few other aspects around security we're improving. There's a lot of work going on right now in terms of hardware support. So hardware security module integration. Not all keys will be stored in software inside of the vaults. We'll use hardware security to hold secret information, to hold keys as well. And then there's the concept transaction summaries. So some secure signing devices provide the ability to present messages to users to basically authenticate a message or to authenticate some kind of activity. And the Vault will be used to actually collate those transaction summary messages and store them such that they can be presented to a secure signing device. And then we've got some integrity checking done there. And I think that's about it. My final slide is... Oh, unfortunately, it's not running. But basically, my final slide was, if you do intend to break into the Vault, there's a 30-second clip, which is famous from the film The Italian Job, which basically says what it says there. It's a shame I can't play the clip. And that's about it. There's a few links here to some important papers, documentation, and some of our support channels. But now, any questions, basically? Yes.
I was just wondering, when you give the JDBC access, is that for read only?
Yes.
Because I was thinking like, hibernate and let someone just get in there and...
So that's a very good point. So internally, some of the work we are doing, so read access is provided only for internal node vault tables. So effectively, any internal node table is read-only access. Then we have different levels of permissioning because then we've got custom contract tables which are writable by flows and by custom contracts. And then, yeah, it's pretty much read-only to internal tables. So there are separate accounts.
And then my second question was, Did you add that because you were having trouble getting performance out of Hibernate?
Well, so we never really perceived Hibernate as, what, Hibernate? Did you say Hibernate?
Yeah. Well, I thought that's what you said for your ORM.
Yeah, so we're using Hibernate for ORM. I thought you mentioned H2. So Hibernate hasn't really given us any performance issues as yet. But having said that, we haven't really implemented any caching layer. So we haven't really been through that process of optimization of Corda because the focus has really been on getting a functional product to market for the version 1.0. So a lot of questions around performance optimization, that really is going to be the focus of Corda, from end of September onwards.
And I can see where you guys need to look at partitioning and other things too, because you can end up being a very large database.
Yes, yes. So there are a lot of aspects around. So it should be possible to scale up a node. So it should be possible to have a single node sharing a single database, so a single vault. So we have got a lot of work to be done around scaling up in terms of node instances, in terms of high availability of the database itself, and in terms of sharing of state across nodes. So there's a lot of work to be done on the scaling side. Yeah. Ooh, nearly.
That wasn't me. For the custom contract schemas,
Yes.
Do you handle versioning? So could you update the schema in the future over time? And
Yes.
If so, what do you do with all the previous data? Do you keep a separate schema for the different versions because it's immutable, or do you update the old data to match the new schema?
Okay, so when I described the definition of a schema object, a schema family allows you to define a series of different versions. So what we do is in Corda we will maintain this. A Corda is configured through a configuration file. That configuration file will tell you you can define which schemas to load up into the Corda app. So we have the ability to have multiple versions of a schema in a deployment at the same time, and then there will be like a migration process. So there may be nodes running at different versions of the same contract, and we'll allow for that to happen up until such time where there'll have to be an agreed migration to a particular version or a minimum version level, and then there will be some housekeeping to be done to take those immutable states off ledger. But there is a secure storage. There's a secure storage table, which is the immutable ledger itself. So the vault is just a view on the original immutable ledger. So original states will never be deleted or removed. So just to clarify, the original states are serialized objects only. They are not exploded into queryable schemas. Yep. Okay. I think it's going to the back.
I think just thinking about what you said a little bit, does the vault actually store the private key material? Because you also then said that you're working on HSM integrations, etc. And then, if it does store the private key material, if you're going to record transactions and they need to be signed, that's sort of interesting because the private key material is sitting right where you obtain the signatures from, right?
Well, so there's a number of techniques that are used in Corda to anonymize any keys that are not your own identity's keys. So there will be no data in the vault there'll be no key information that you can query that's not relevant to your own identity. Everything will be anonymized in some way or form. And that's pretty much how there is no way you can query other people's keys. And I think, Mike, in the later talk, you'll understand a lot more about how we manage privacy and how we manage key management. And I recommend you stick around for that one.
Sure. Just one more question. The off-chain piece of the vault, is that sort of replicated, or is that specific to just one instance, or?
So the off-ledger information, it can be replicated. There is information off-ledger which is inside of the node's database schema itself, which are the transaction notes, which are node-specific but not shared with any other participants. Then there's your own basically it could be any reference data outside, and you can replicate either way. There's no restrictions there. And one more question I think we had here.
How do you maintain consensus between different vaults which share same transaction data? Is that predominantly through the flow?
So remember that the vault is specific to a node. So any state or any information that goes into the vault has been through a series of relevancy checks. When a flow receives a transaction, before it goes through a series of notarization steps, but before any data gets into the vault, it goes through a relevancy check to make sure that the keys and the ownership of that state can be stored in that node's vault. So there's no real consensus of vault data because every vault is different. Every node has its own vault.
For example, that some transactions only move to certain vaults and not others. How would, I guess, you control that?
So it's all done through keys. So basically a contract. So when you define a contract in Corda, one of the attributes is participants. Those participants are the public keys of the participants. And basically data only moves between Corda nodes according to who's participating in that contract.
The public address of the participant as well?
The vault is associated with the legal identity of the node, which has its own private public key and certificate. And all relevancy checking is done around the keys and certificates. Yeah.
Very quickly, sorry,
as
thanks.
it's close.
Thank you. Just in theory, would it be conceivable that at some point I would say, because my database has grown very large, take all the consumed states that are older than a year and delete them or copy them somewhere and delete them off the database?
Yes.
Would that break something? Or it would?
No. So as I mentioned earlier, the vault itself is a view on the immutable ledger, which is the kind of serialized blob storage. So what we envisage is that we'll produce some archiving tools and housekeeping tools that will allow you to actually do some housekeeping and take away the consumed states out of the vault into some kind of secure storage of your own making, and then